Let's talk about why the graph data model has better query performance than the relational data model if we have deep and complicated data relationships. We are going to use this organizational chart for our discussion. An organizational chart is a hierarchy graph. Pay attention to this label column. The label indicates where within the organizational chart an employee is located. When we work with the data, we will create a graph. In the graph, we will have this label data. If we use the relational data model, we will store all data in a table. This is an example. Then we will use the regular SQL code to work with the graph to create the graph. If we use the regular SQL code, the data relationships will be calculated during runtime. Keep in mind, SQL joins take resources, and there may be a latency in a busy environment and if we have a lot of data. Also, when we use the regular SQL code, in this example, we are doing the recursive processing. The recursive processing is similar to SQL self-joins. If we use the graph data model, we will have two tables, the node table and the age table. This is a node table. In the node table, we will store our regular data. This is an example. This is an age table. In the age table, we will store the complicated and deep data relationships. The data relationships are stored in the database and they are ready for use. This will greatly improve the query performance. This is an example of an age table. When we use the graph data model, we will use the match function to work with the graph. The match function is available in many graph processing languages. Also here, we are doing something similar to self-joins. Lastly, keep in mind the graph data model promotes data redundancy and the relational data model avoids data redundancy. The redundant data will improve the query performance. Simply speaking, the graph data model does denumerization. The relational data model does numerization. This is the end of our discussion.